Welcome to the project demonstration of PID control for CPU temperature of Raspberry Pi. So here we are going to monitor and trying to reduce the temperature of the CPU while we are processing the project execution. So like nothing but for example, we are doing a task, means we are given a task in Python language to the Raspberry Pi 4 we are using, and the task is we need to get the temperature and humidity from this DHT22 sensor, and the second is display the same data on the LCD, and third thing is uploading of the same data to the cloud platform, there's a ThinkSpeak using a Wi-Fi network. So while the execution of these three tasks, so to make overheat of the processor, we reduce the processing time. So instead of providing the more time to process and fetching the data and execution, so we have provided the less time to then the system may get heat up the processor while doing the task in high speed manner. So and we have interfaced the DS18B20 temperature sensor, which is continuously measuring the surface of this processor, means surface temperature of this processor, and uploading the same data to the ThinkSpeak. So while doing that, so initially the system lets the processor getting heat up, and then after once it crosses some threshold value, for example when we switch on the kit, then the system will capture the initial temperature. Then when the temperature increases about 1.5 degrees more than the processing speed, due to the processing speed, if the temperature increases more than the initial temperature, for example consider, so when we switch on the kit it's going to be 31 degrees, and when the process is going on, keep on, then the system, if the temperature of the processor is increases 30 plus 1.5 more than degrees, so let's consider 31, later on 32.5 more than that, then the system will trying to place the operation in PID controller manner, so that the PID controller will taking care of PID controller logic will taking care of upload the data to the ThinkSpeak and fetching the data and displaying the data, so that we can gradually decrease the processing processor temperature while removing the more load on the processor. So here we are interface the, as we discussed, DHT11, DHT22 sensor, and which was interfaced to the microcontrollers Raspberry Pi model Pi 4 at pin number 727, and 17 pin is interfaced to this DS18B20, and pin number 5 to pin number 23 interfaced to this LCD module. So let us see demonstration. So this is the data we have loaded into the ThinkSpeak while we testing of the project. So the field 1 is CPU temperature, and field 2 is a temperature from the DHT22 humidity also. So we can erase this old data and we can fetch the new data. So before erasing the data, go to data import exports. You can download the data. So it will be downloaded in Excel sheet. Open that. So it will be open in Excel sheet format, so which will consist of date and time along with samples. Right. So when we access the data from Excel sheet, we get to know that it consists of date and time, and how many samples till now we have collected. So the entry ID nothing but how many samples till now we collected, and field 1. So as we have know from this private view, there's a field 1 is the temperature of the CPU, and the next temperature and the surrounding temperature near the sensor DHT22, and next is the humidity. So after you took the backup, now go to channel settings, and in that only do clear channel, don't delete that, only clear the channel. So once the channel got cleared, confirmation done, now go to private view. So private view to access the live data, channel settings to clear the channel, data import export to download the data to get the backup. After you done, that's your wish. If you want to clear the data, you can clear, otherwise you can keep as it is, and we can clear it whenever you want. Now go to hotspot settings and configure the hotspot name to project 7261 without any space, without any capital letter. Password should be 123456789. AP band should be 2.4 gigahertz. So after successfully done these settings clearly, now on the hotspots and data, and log into ThinkSpeak as we have done already. Now on the power supply to this Raspberry Pi. So wait, it will take around 20 to 30 seconds to boot into the operating system which we have loaded inside the memory card, and successfully booting the system will show the welcome message on the LCD screen, and also one device will be connected. Right, so welcome to the project. and the next it is connecting to the internet. So now you can see the Raspberry Pi got connected in your mobile phone. Now you can stay on the screen. So it's trying to get the internet, means that's why you need to on the data on your mobile phone. It's connected. And now let us check the temperature and humidity. So the above line is sensors data from the DHT22 and the CPU temperature is 31.7 degrees. Now this data is captured inside this our Raspberry Pi 4, the initial value. Then when the process is going on, if the temperature increases, so then we need to place this sensor near the CPU so that we get to know about the temperature will be raised slowly. And when it crosses the 1.5 degrees centigrade, that's indication of the processor core units getting heat up due to the high processor speeding of the data. Then the system will start running the PID controller to reduce the temperature of this processor core unit. And you can see the temperature or anything. If you want to increase manually, we can place any heat object near this humidity sensor so that it will affect the sensors data. Right, you can see the temperature of this. Right, so the sensors data is there, and CPU temperature also. Right, and so the data will be uploaded to ThinkSpeak for every 15 seconds of duration, as ThinkSpeak accept the data for the duration of 15 seconds of interval. Right. Right, so as the temperature got increased, so now slowly it will be started decreasing the temperature, and it will take some time to execute that.